Okay, so at this point in the series, you might be wondering, can I use a decision tree for what we're trying to accomplish here? And many thanks to those of you who have asked this question, and the answer is not really. You see, decision trees happen to have some very important flaws when it comes to putting intelligence into your application. They are great for doing trivial decision making, but if you want to add anything of any serious intelligence into your application, you need something more. Make sure to watch till the end of this video, where I'll discuss the important architectural and feature limitations of decision trees. Today we continue with part 3 of our journey, looking at prompts, which are an important part of our ADI nodes. I'm your host, Sean McKenzie. Thank you for joining once again on my channel on data engineering. In this episode, we go back to our application domain intelligence playlist on Microsoft Access, and we're going to talk about input prompts. Now, input prompts are a very important part of the ADI node, and they are part of the reason why ADI nodes are adaptive and also context aware. So today we're going to do some programming in VBA, and we're going to do an input prompt subroutine, and then we're going to do an input prompt subroutine, which is going to process multiple prompts if that's what we need in any particular node. Let's get to it. Interested in more topics like these? Make sure to check out my Patreon. The link is in the description. Okay guys, so today we are continuing on our journey in our ADI node creation, and you can see this is the file we're using right here. And in our last episode we built this ADI condition table. We made a shift form to emulate some kind of user form, and we also had this ADI module that we started, and those were the 3 things that we created. And today we're going to be building prompts. But here's our ADI condition table. If you have not watched that episode, make sure you go back to the previous episode so that you understand about how ADI conditions work. The important feature being dynamic programming, which I introduced to you guys, that uses some code that's outside of the editor so that we can create dynamic situations and contexts and things like that. And so to build our prompt table, we'll go ahead and we'll use the create ribbon. We'll go new table design, and then we'll just go ahead and create our table. So I'm going to call the key field prompt ID, and I'll put an auto number as the data type for that one. And that's going to need a node ID, which we don't have a node table yet. We are going to get to that. Today we're going to explore node 0, which is going to be our test node, and then we'll go from there. We're going to need a prompt order, so for any given node in our what we are going to call our ADI system, a prompt order. So you can have more than one prompt. It might be, a yes, no, and then maybe an input or something like that. And then we're going to have a type, which is going to be either yes, no, or input. And we are going to introduce further types as this playlist goes on. We're going to have other types like lists and things like that. But to get started, we're going to start with the very basic ones so that you guys can see how the prompting works on an ADI node. And then we'll add a caption. So that's going to be the caption of, say, the message box that we use. We'll reduce that to a 50 field size for the type and the caption. And then we're going to have a message, which we'll call text. We'll call that prompt text. And that'll probably be longer than the prompt caption, which is the text that you see in the header of a message box. Usually that's kind of like a title. And that'll do us for having a table here. So we've got all the fields that we want, and we can hit save for that, and we'll call this one ADI prompt. And that's going to give us a table that we can store all the prompts for any given node in our ADI system. So there we go. We can hit save, and I did not define my primary key, so it looks like it gave me a warning. We can say yes to this message, and it's going to put that primary key onto the auto number field because that is the best field for our primary key. Make sure you always put a primary key on your tables. It is one of the cardinal sins of working with data if you do not have a primary key. And so there we go. We've got our ADI condition, and now we have another table that says ADI prompt. And so now we have two of the building blocks of our ADI node. We've got a condition and a prompt, and we've got node 0 already loaded in there as the default if we were to make a new record. And you can see we've got an order, we've got a prompt type, and we've got a caption and some text. And so these are going to help us to collect information from the user so that the ADI conditions can be evaluated to say or to direct the flow of the ADI system down the appropriate branches. And so that's what makes it very, very powerful, is that it's dynamic. So I could create a new record like you see here. That's ADI with node 0. Prompt order is number 1, and it's a yes/no prompt. And we could say, you know, is it working as our title? And then is this prompt working as a question? And that would give us sort of like the very basic ADI prompt, which will be a yes/no message box that you guys probably already know from programming with Microsoft Access and Visual Basic for applications. So of course, if we build an ADI prompt table to collect information from our users, then of course we need an ADI answer table. And the answer table will be a simple way for us to collect the information and store the information from the user after they have answered their questions. And so we'll store this in date order, but there are some fields that we're going to collect, and you might add additional fields to your answer table depending on how your system will work. And so what we're going to add is our username. That's going to be whatever user is currently answering questions in the ADI system. We will store the prompt ID because we want to know what the prompt was that they answered, and then we also want to know what their answer was when they answered that particular prompt. And so this is going to give us a nice way to store that information for each user. And we'll also put a date stamp on there of a date time type, and we'll put a default value of now, so that every time we insert a record into this table, that date stamp field will be automatically filled in, and we don't need to worry about that. Now I'm going to specifically set the primary key by right-clicking on that first column there, unlike last time where I forgot that step and then it reminded me. And I will click Save, and then we put in our ADI underscore answer as the name for our table. And then we can see that by expanding our access objects here. And now we've got this nice little table with a username, a prompt ID, answer, and date stamp. Now we may add more fields to this. You might add other fields depending on how your system works. Certainly it depends on the context of how you're using the ADI system. You might want to collect different information, but this is kind of like the very basic skeleton information that you need in order to collect that data. So let's go ahead and click on that ADI module to open the Visual Basic for Applications editor, and we can start doing some coding. Now I'm going to add at the top of our module here, I did not do this last time, this is an option. I'm going to put option explicit so that I don't use any variables that I have not declared and those types of things. And so this will make it nice and easy for us to find if I make any bugs, which I often do. I often make tons of bugs and I break systems constantly. So here we go. We're going to start our subroutine, and we'll call our subroutine do prompt. So this is going to do one prompt in our ADI system, and we are going to pass into this prompt the prompt ID that we want to evaluate, and that's what the prompt LNG prompt that you see in the top in brackets is. And then we'll go ahead and we're going to build a little subroutine that you guys have seen many times on my channel. We're going to specify a database, a record set variable, a string for SQL, and then we're going to get some variables to load for our ADI system, and those will include the order, which will be a long integer, the caption is a string, the message box is a string, or the message in the message box is a string, the type will be a string, and then we're going to have a return value, which is essentially a variant, and that can be anything, and then we'll put in a return string, and we're going to use that for the input box type. And so we'll go ahead, we'll set that database variable equal to the current database, and then we'll set our SQL string equal to select star from ADI prompt, where the prompt ID is equal to, of course, the prompt that we're passing in. So that's the prompt that you see at the top there. And then just for good measure, I will add a semicolon onto the end of this SQL string to make it proper SQL. And there we go, we've got our SQL string as select star from ADI prompt, where prompt ID equals the prompt, the prompt number. And so there we go, we can use that one, and we'll set our record set equal to db.openRecordSet, and we're going to pass in that SQL string, and we're going to use db.openSnapshot, which is a read-only record set, and that makes it nice and easy and fast to use from either native access tables or ODBC tables or things like that. It's going to be nice and fast, and it doesn't ask for an updatable record set. And so there we go, we've got our snapshot open, and of course at the end of our procedure we want to close our record set and set those equal to nothing, and we'll put those behind sub exit so that we can jump to that point if we need to in other places in our code, and we are actually going to set one of those right now. We'll set another line label as sub error, and you'll notice that I put exit sub just as the last line under the label sub exit, and that means that it'll go through that code and then it'll exit out of the subroutine, and so the error sub is outside of that. And I've done this in an error handling video. Make sure you check out that one. I'll put the card up at the top here, and we'll continue on. So in our error, the error part of our routine here, we're going to put a message box that says, hey, there was an error, something bad happened and it broke, and then we say resume sub exit. So that's going to resume it, so it makes sure that that record set gets closed no matter what happens, because we put on error resume next. And what that means is that in that last little block there, even if it's open or if it's closed, if it throws an error, it will try to close it, and then it'll just continue on regardless. So it'll still run those set statements even if we get an error trying to close that record set. And so there we go, we've got our three blocks. We've got the main block, the sub exit block, sub error block, and we've got a message box for our error, which will resume after, and then it'll continue on and go into the sub exit if we do get an error, and we'll add that on error go to sub error. We're going to put that at the top at the end here, just under the str return. We'll return to that and put that at the end, but we want it to break right now if it breaks, because we want it to break in the editor, which will be nice and easy to find that error. So that's one of the things you usually put on last, is you'll put the on error go to sub error, or whatever you want to call the error block. You put that on last after you've tested it. So here we go, we've got our record set. So now we can go with RST. I'm going to use the with end with. Make sure to check out my video on that one. I'll put the card at the top here. If you're interested in that one, come back to it later. But you can get the sense of it here. It just reduces the amount of complexity in our code. So I put with RST, and then our long order variable is equal to exclamation prompt order. str caption is equal to the caption, the message is equal to the text, and the type is equal to the type, without having to specify RST, exclamation, prompt order, etc., etc. So that reduces the number of characters we have to put in there, and away we go. Now, since these are system tables, we are going to make the assumption that there aren't any errors in the system table, and so we're going to assume that this is not null. So you could put, NZ or NZ with the brackets there, and that will convert a null into a 0 so you don't get an error and things like that. But my code here is going to assume that since these are system tables, we're not going to have nulls in there, but you can certainly account for those if you need to in your code. So if you keep getting errors related to nulls and things like that, you could go back into your code and use that NZ function that I showed you up above there on the prompt order just a minute ago. And so moving on, we can now look at the type of prompt that we need to give to the user. So we're going to use a select case for this statement because we're going to have a yes, no, we're going to have an input box today. There could be many other types, and we're going to explore how to build those in later episodes, things like lists and other kinds of inputs. But for today, let's just look at our yes, no, and our input box so that we can gather information from the user based off of some dynamic programming conditions that we did in the previous episode. So here we go. We're going to say if it's a yes, no prompt, then let's use the yes, no message box to gather the information from the user. And so we've gotten the question from the information that's in the prompt record, and so we can go ahead and put that information into the message box. So the message for the message box will be the message string, and then we'll use a yes, no plus VB question, and then we'll put the caption in the caption for the message box. And then we can do things like we can say, if the variant return, which in this case will be VB yes or VB no, those are constants in VB, we can say, if it's VB yes, then we'll return yes. You could use integers for this. It might be 1 and 0 or whatever, depending on how you want to build your system. But for today, I want to keep it simple. If we get, VB yes, we'll say yes. If we get VB no, we'll say no. And that'll be more than good enough for what we need today. So of course, once we have an answer, we want to write that answer into our table. And so I'm going to go and put an RST add as a new record set up here because we're going to add information into our table, whether it's a yes, no, or whether it's an input box. And of course, the input box is free-form text, and that can be very dangerous, and we're going to talk about that as we go through here. But we've got our record set, which comes from the table based off of the ID, and so that's one record set. It's a snapshot, and that is non-updatable, but we're going to add another record set to our system here, and this one will be updatable because we want to have an updatable record set for the answers. And so we're going to open that ADI answer. We're going to open db.openDynaset, which is updatable. Now, if you're using Azure SQL or if you're using SQL Server with an ODBC connector, you'll use that DBC changes so that you can collect the ID that's created and things like that. So make sure to remember, if you're using SQL Server, SQL Express, or Azure SQL on the back end, to add that DBC changes on there as an optional argument. Now we are also going to close our record set just in the same way that we do with the other record set, and then we're also going to set that equal to nothing, and that's going to release the resources of our system. And so now we've got an addition record set, and we are not going to be executing an SQL string with the values, because we are going to do an input box in a minute, and the user could put in, delete everything from some table. They could do something nefarious, and so we want to make sure that we treat that either as a parameterized query, or in this case we're going to be using a DAO record set, which handles all of that stuff for us. So we can actually put in all kinds of bad entries into this input box that we're going to see down below. We're doing yes, no right now, but that's going to help us a lot with security. Okay, so now we've got our RST there, and just like before, we can use the with and end with statements, and so we can go ahead and do with RST add, and we'll do dot add new, and that's going to add a new record. Oh, I used the single quotes. There's my Python programming coming out. So there we go. We'll do exclamation username is equal to user. We'll go back and set that later. You can change the user to whatever user is in your system. It might be in a temp var, or it could be in a global variable or whatever, but today I'm just going to put user in there. We'll say the prompt ID is the prompt that has been passed into this procedure that we looked up. So that would be our yes, no, or our input box prompt. And then the answer is equal to whatever we got for the return, and we'll go dot update at the end of that. And then we'll go end with, and that will give us everything we need to add a new record into the RST add, which is the answer table. And so that is security wise and everything like that. And so that's what we want to do, especially when we're dealing with dynamic programming. We need to make sure that we validate user entries so that they can be put into tables and not destroying your system. And so we'll move on to the input box, very similar to what we did before. We're going to say our return value is equal to input box with the message and the caption, and then we'll use the same structure that we used before, using with and end with. And so there we go. We've got our RST add going, and we can do the same as we did just up above there. We can do an add new, and then we'll set the value of the fields equal to our values that we have in our variables, with the exception of the username, which we'll set to user. But this is where things get interesting from a security standpoint. You can see that we're getting a return value there from our input box, and that could be anything. And so users could put in database commands or all kinds of different things in there. And so that can be dangerous not only in programming, but also in database, on the database layer. And so whenever you retrieve user input in order to do dynamic programming or to do database commands and things like that, you have to be very careful on how you handle those. And so in this case, what we're going to do is we're taking that string value. We know that input box returns a string whether they hit cancel or whether they put in a value, and we are going to use the RST add with an add new and a update, and that is going to allow us to have a parameterized query in a sense. You can see we're using the DAO objects here, and I'll just put a note. I put a note there saying can be null, can be unsafe, and it's kind of the same as doing parameterized query in the sense that it's safer to put data into our table that way without being exposed. From there, we can test this out in a sense by hitting our debug compile, and that's going to tell us if we have any crazy errors in there or typos or things like that that are really going to screw things up. That gives us kind of a nice little subroutine called doPrompt, and now we can actually try and use this by putting in a prompt. So we can go view and then immediate window, or you can go Control G and that'll give you the immediate window. And here are our fields. Now we've got one record in our prompt table, and it has the node ID of 0, and it's a yes no prompt. And so if we run this function, we should get a yes no message box, and it should save our value in the table. So let's try that out. So we'll go do prompt. Oh, it did work. Okay, so there we go. We have, is this prompt working? And that's what we want to see there. And we can click yes, and then we can look at our table, and hopefully everything got stored. So we'll go to our answers. We'll double click on that, and you can see we do have one answer in here. There we go. So we can see that user named user answered the prompt number 1 with a yes, and it's got a date stamp on it, so we know exactly when that happened. And so we can use that for things like asking, was the last answer yes to the last question that was answered? So we can create some nice little logic along those lines that is kind of independent and allows us to do different kinds of programming. So we'll run it again. I put my cursor in there and hit enter, and we selected no this time, and there's our ADI prompt. And if we go to our answers, there we go, we've got our second answer, which is prompt ID 1 with the answer no. That happens shortly afterward. And so that's very, very handy. Now we can try and do a little bit more. So let's go ahead and add a second prompt to our sequence for node ID 0. So these are both attached to our test node, which is node ID 0. And we're going to add the order as 2, which will make it the second one that's executed. And we can go input box. Now we're going to test the input box, and we'll say enter stuff, and then we can say please enter stuff. And that'll give us a little prompt that allows us to type into it some user some stuff in there. And we'll add on another prompt for a yes no, and just to test out the sequence. Once we build that procedure, we're going to prepare ourselves here to build the do prompt procedure, which will run all of the prompts for node ID 0. And there we go. So yes, no, are you feeling great? I put that in the wrong one. Here we go. We'll put that in we'll say the caption is something something simple like feeling. How are you feeling today? And then we'll paste in the question into the prompt text. So there we go. We now have 3 prompts in order for node ID 0, and this is what a node's prompts might look like. And so they all belong to node ID 0. We don't have the node architecture in there yet. We're still testing the pieces of our puzzle, and it's all going to come together when we put the node together in a future episode here. And so now we can test out the single prompts, each of those separately. We can say do prompt number 2. Oh, it opened up above there. I will include instructions on how to place this, because you can actually say where this one opens on screen by adding some coordinates. I'll show you that later, or I'll put it in the description below. Make sure to remind me in the comments if I have forgotten to do that. And we can run prompt number 3, which is a yes no, and we did that as well. So now we can look at our answer table, and now you can see there are some more answers. And so we've got a yes for the third question. For the second question, that we put in stuff there, and we are able to collect freeform data and yes no data from the user as part of our node in our ADI system. Okay, so now we're going to go ahead and we're going to create our subroutine for doing all of the prompts for a particular node. And so we'll create a subroutine called do prompts, which will, as you guessed it, make use of the subroutine do prompt. So I'll just leave a little message at the top here saying what we're going to do. Processes input prompts for a node, and then we're going to use much the similar structure. Oh, if I could type. Much the similar structure that we used in the other subroutine, which is to use the DB as database, and we'll use an RST for our DAO record set and a string for our SQL. And so we can go ahead and set those just like we did before. This is a much smaller subroutine than the other one, and so I'm not going to include some of the error handling, although you could do that if you'd like to. I don't think there will be many errors on this subroutine, but you never know. So we could add that later if we'd like to, but for now it's very simple. We're just going to have a simple SQL string here, just like we did in the other subroutine. We'll say select star from ADI prompt, where node ID is equal to, and then we'll put in the node as a long, which is what we're passing into this procedure. And then we'll order by, of course, the prompt order, because we want the prompts to be displayed in the right order. Sometimes you'd like to do a yes, no, and then collect some data, some freeform data, or you might want to do it the other way around. But this definitely gives you the option to do that by having the prompt order field, so you can order those. Next, we'll set our RST equal to db.openRecordSet, and again, we'll use that snapshot, the snapshot type, which is a read-only, and it's a little faster and a little nicer to use than using the default Dynaset. And then we can loop through our record set here, and we can basically look at each prompt as we go through. So we're using that do until rst.eof. That means end of file, or the end of the record set. And make sure you remember to put that rst.moveNext in there. If you forget that one, it will start an unending loop that will lock up your computer or lock up the app, and it'll show as not responding, and you'll have to shut it down using the task manager or something like that. And as you can see, we've created the prompt as a long there, so that's the actual prompt, and we're going to set that equal to RST prompt ID each time we go through. So again, here we go. We've got our do until rst.eof loop, and inside of our loop, we are going to load that variable with the prompt ID on each pass, and then we're going to do prompt for each of those as we go through. And then we'll rst.moveNext on each of those, and then we'll close that record set, and we'll set everything equal to nothing, and I'll go compile. We'll do a debug compile just to make sure we're not doing anything crazy here, and then we can go ahead and give it a try and see if I broke it yet. So here we go. So we'll do prompt 0. And it says, is this prompt working? We'll go yes, and we'll enter stuff. We can enter stuff in there, and we can put in some text. This is interactive, and that should do for now. We can go ahead and go OK, and then it asks, are you feeling great today? I'll say yeah, because I feel great today. And that should give us some answers into our ADI answer table, and you can see there are our 3 answers for that prompt. Those happen to be prompt 1, 2, and 3, and we gave yes, and then this is interactive as our freeform answer, and then yes, and that is exactly what we want to see there. That is fantastic. So if we bring up our code again, we can have a look through. Actually, you don't need the brackets after do prompt there on your argument. You can just put the long in there, and it is useful to talk about how we might evaluate our returns. Now this is the yes no prompt where we gave the str return, but if this was a long string, you could grab the left 255 out of that, or you could do something else. Now with this one, where we actually are receiving the input box data, that could be very long. Right now we've got a 255 short text in our table, so you could have the option of prompting the user to put in 255 or less, or in our case we're just going to change that answer field to a long text, so the user can put in as many characters as the input prompt will allow them to, and that will go directly into our table. Okay, let's test that out again. We've got our do prompts here with the 0 node as the argument, our test node. We'll hit enter, and we'll say no to the first question. We'll say other stuff for our answer to the second prompt, which is an input prompt, and we'll say, are you feeling great today? And we'll say yes, we are always feeling great. So there we go. We've got 3 in there. We can do the same thing that we did before. We can look at our answer table, and you can see there we've got 3 more answers, as if the user had gone through that one particular prompt in a different way. And so you've collected data 2 times from the same user with different results at different times, and that's very, very useful, and it is the purpose of the ADI system prompts to collect that data from users depending on what conditions were found in the same node. And those conditions could include all kinds of things like the price of a product on a page or who is logged in and all that kind of stuff. Now, just before we wrap up here, let's bring our code window back up. We're going to fix a couple of things that we talked about in the lesson there. Unless you're programming .NET, you don't need to put these brackets around here. You can just put the argument with a space after that for the subroutine. And we're also going to go and put our onError go to sub error. We tested it without the error trap so we could see it in the editor, but your users will not want to do that. They'll want a more user-friendly error, and so we'll put that onError go to sub error. That's going to push the program flow to a more manageable message box, which will then go to the sub exit, which will close and release resources. And so in a nutshell, that is how you can build prompts for your nodes in your ADI system. Okay, so for those of you who have been trying a decision tree instead of an ADI node, which you haven't learned ADI nodes yet, so you might have tried to use a decision tree. I tried to use a decision tree many years ago, and decision trees, when I say decision tree, typically those are implemented with a self-join table so that one parent record can have many children records in the same table. When compared with ADI nodes, a self-join table is very static, and therefore it is not context aware, and it can also not be adaptive. Because ADI nodes use dynamic programming, they're able to be self-aware, and they're able to look up any kind of condition from the time of day to which user logged in to what a particular situation might be between pricing among many different products on a product screen. So an ADI node will always be more dynamic and powerful than just using a decision tree with a self-join table. And that leads us to the next big difference between ADI nodes and decision trees, and that is that decision trees are parent-child relationships where every child knows the parent node, and that can be very helpful in certain situations. However, because each child can only have one parent, that makes it very inflexible for applying to certain problems. ADI nodes do not know which parent called them, but they can look back at the history of what has been entered by users, and then it can dynamically decide what the next step might be for that particular user. Kind of like Quagmire's children. Nobody knows who their parents are. One of the great examples of how ADI nodes work better than a decision tree is when you want to implement a survey that, say, has 100 questions in it, and say your user goes through all of the branches of the decision tree and get almost to the end after answering all of these questions, but the outcome of this question, if it is a certain answer, will send them back to, say, the third node down in the tree. With a self-joining table, you have to have an entire copy of the entire tree below the third node as a copy of itself, increasing the number of questions you have to maintain by a huge number. Now imagine that 50 of those questions have callback answers that go back up into the tree. Then you can imagine that the number of questions that you have to maintain that are duplicates goes up dramatically, and that makes for a huge mess. An ADI node that is far down in the tree and evaluates a certain way can simply point to a node that's further up in the tree, even if it's a node that was already processed. And of course, the other thing that ADI nodes can do that a traditional decision tree cannot is they can do actions. And so every node can do an action, and so that is what we're going to be covering in our next episode. And once we're done with that, we will continue on and we will actually start building our node, and you can see the design of what an ADI node actually looks like. Stay tuned for more. Need an easy-to-use time entry system for your team? Make sure to check out my time collection solution. The link is in the description.